When working with word problems that involve right triangles, it's important to know what some of the terminology means. And some of the stuff they can say is line of sight, angle of elevation, angle of depression, or angle of inclination. If you got these in the problem that you're working with and you don't know, then it's going to make it hard to solve. So here's what they mean if it does happen to pop up in your question. So let's look at our first one. A 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? So when I'm dealing with right triangle questions like this, I like to draw a right triangle so I can kind of visually see what's going on. So I'm going to draw myself a right triangle. And fill in what I know. Well, I know that the ladder leans against a building and it's 20 feet long. So I know that the ladder leaning against this building here is 20 feet. So the hypotenuse is 20. That's a terrible 2. There we go. And I know that the angle between the ground and the ladder is 72 degrees. I still need to know how high does the ladder reach on the building. So I'm going to say that the building kind of gets cut off right here, just for my sake. So how tall is this, or how long is this unknown side? Well, that's all the information it gives me, so I got to figure it out from here. Now when working with these right triangles, if it's possible, stick with sine, cosine, or tangent. Make your life a little bit easier. Well, from here I see that this angle, 72 degrees, I see that this unknown side x, which is on the opposite side, and I see that I have a hypotenuse of 20. So I have this angle measurement here with an opposite side and a hypotenuse. Well, opposite and hypotenuse, my mind immediately goes to sine. So I'm going to do sine of 72 equals opposite over hypotenuse. And now I can just solve for x. So I'm going to multiply the 20 over to get x by itself. So I'm going to get 20 sine of 72 equals x. And now what is sine of 72? Haven't a clue. But your calculator does know it. And when you plug it into your calculator, be very mindful that this is 72 degrees. Make sure your calculator is in degree mode, not radian mode. If it's in the wrong mode, you're going to get a bad answer. So be doubly sure. So we're just going to do 20 times sine of 72, and that's going to give me 19 feet for x. So how high does the ladder reach in the building? How high or how long is this side? It is 19 feet, because that's the unit of measure from the beginning of the question. Next, a 96-foot tree casts a shadow that is 120 feet long. What is the angle of elevation of the sun? So, again, I want to do a right triangle. Obviously, this one's bigger than the last one. And I see that a 96-foot tree casts a shadow that's 120 feet long. So the tree is going to be here, so 96 feet. And cast a shadow that's 120 feet long. So the shadow is going to run along the ground. So 120 feet. Now this is what I know, but it's asking what is the angle of elevation? Well, I don't know what angle of elevation means. Well, we can go back up here. Angle of elevation. If the object being observed is above the horizontal, then the angle between the line of sight and the horizontal is called the angle of elevation. Well, the line of sight is just if an observer is looking at an object, then from the line, from the eye of the observer to the object is called the line of sight. So using those two facts, I can see that what they're talking about is right here. Because the sun, draw a picture of a sun, is casting this shadow here. So the angle of elevation, I'm trying to find this degree measurement, this angle here. So I have this angle measurement, and I'm trying to find I have an opposite and I have a hypotenuse, or I have an adjacent, excuse me, opposite and an adjacent. So using those two things, my mind immediately goes to tangent. So I can say that tangent of theta is equal to opposite over adjacent. Now I need to solve for tangent. The only way I can do that is I am going to take the arctangent of both sides. And when I take the arctangent of both sides, the tangent over here cancels out, leaving me with just theta. And over here, I'm going to have arctangent of 96 over 120. And again, what is that? Haven't a clue. But my calculator does, so I'm just going to plug in arctangent of 96 over 120. And when I do that, and again make sure that it's in degree modes because that's what we're working with here, my answer is going to be, to one decimal place, 38.7 degrees. So my angle of elevation of the sun from someone standing right here is 38.7 degrees.